The last of the factors we are going to talk about is catalyst. A catalyst is a substance whose presence increases the rate of a reaction but remains unchanged at the end. So they are just there to help make the reaction go faster. Their presence will ensure that the reaction goes faster, but they are not going to be involved in the reaction. So here you have the reactant, you have the products. Now the catalysts are not added to the reactants on the left, but the catalysts are placed on the arrow because they are not taking part in the reaction. So the reactants could be mixed with the catalyst, but the catalyst is only affecting the rate of the reaction. It is not taking part in the reaction. Now let's see how the catalyst works. Here we see an exothermic energy diagram. The reactants have more energy than the product, but instead of the reaction going straight down, there is a certain energy that each reactant must have. Each particle of the reactant must have, which we call the activation energy. So this is the normal course of the reaction. The activation energy is high up here, and that is the normal course of the reaction. So each element here, each particle here, must be able to have energy with which it can overcome the activation energy before it loses the energy to form the products. Now the enzyme acts by lowering this activation energy demand. It lowers this activation energy. So instead of the particles moving all up here, this time around a shortcut has been created, and then the particles will need to move just here, okay, before they lose the energy and then they form the product. So the catalyst has reduced the activation energy and then created a new shortcut which most of the particles will have or will be able to have that energy. This energy, activation energy over here, the initial one is very high, so not all the particles could have that amount of energy. But once you put the catalyst in there, it lowers the energy demand, and then most of the particles will then be able to afford that energy demand and then form the product, so the reaction can go faster. Enzymes are biological catalysts. Now enzymes are protein molecules. We learned that proteins are made up of several amino acids. Okay, so enzymes are protein molecules that are biological catalysts. They are biological catalysts because they are found in living systems, and then their actions help increase the rate of certain reactions. Now before they can act and act well, they require optimum temperature and pH. Optimum temperature is the temperature at which the enzymes could work best. Now when the temperature is too low for a certain enzyme, it will not act at all. It's just like we having a very cold weather. We are a bit slow in the cold weather. When the weather is very hot, we are so uncomfortable. The same applies to the enzyme. When the temperature is too high, the enzyme will feel uncomfortable, and then it could even result in the enzymes being denatured, and consequently they stop functioning. So enzymes require optimum temperature, a temperature at which they work best, and then pH. pH refers to the acidity levels. Certain enzymes act in acidic conditions, other enzymes act in basic conditions, so it has to do with where they are found. Okay, so enzymes are biological catalysts that are protein in nature, and they require optimum temperature and pH to function. Transition metals are also catalysts. They are also catalysts. Now we know that on the periodic table we have two groups, and then we have the other groups here. The transition metals are the blocks in between the two main groups. All the metals found here are good catalysts.